Thanks very much, Chris, for the kind introduction, and especially for adding in the part about my granddaughters. They are the joy of my life, mine and my wife's, and because she does get a lot of credit since she played a small role in delivering our son, who is the father of the 3 granddaughters, and our daughter, who is also in this area. It's a pleasure for me to be here this morning. Artemis, thanks very much for allowing me to join you all. As I look around the audiences, and I had a chance to talk with some of you before we started, and then listening to Chris's introduction, I thought to myself, they must be tired of hearing that introduction, and some of them probably have it memorized by now, since many of us see each other in lots of fora, and hopefully you're not getting tired of hearing me say what I say. I don't know how many of you know the joke about the guy who was lecturing one time, and on the way he decided to change places with his driver, and the driver said, "Shucks, anybody can give that speech." And so he said, "Okay, you think so? Why don't you just do it?" And the driver gave the gentleman speech, and it was some technical presentation. Went to the Q&A, and the first question came up, and he didn't have a clue. And he said, "That's such a simple question. Even my driver can answer that question." Pointed to his driver. Well, my driver could deliver this talk today, but since I couldn't talk Israel into coming in, I am embarrassed to say, and Rebecca down there, who is with me today, Rebecca Powell is my shadow today from Wallop. She's in the NASA First program, and we got about halfway here, and I went, "Oh my goodness, I forgot my glasses." And so Israel, the driver, said, "You can wear mine." I said, "Well, Israel, I don't know about that." And I tried them on, and they're just like my wife's glasses. I can wear hers, she can't wear mine, and everything. So my driver is here giving this speech today. Again, let me thank you for allowing me to participate. My deputy, Lori Garver, who I think all of you know, really wanted to be here, and through, bad fortune and good fortune, through good fortune, she was supposed to be in Japan this week. And so I agreed to take her place. So that's why you have me and not her. And she sends her apologies at not being able to be here. I think all of you know, because of the tragedy in Japan, we're not traveling there right now. But I'm here, so hopefully you'll let me live through this. It's amazing and gratifying to see so many people with passionate interest in the International Space Station. ISS is the centerpiece for our human exploration and our human spaceflight endeavors in the coming decade. I like to say it's our anchor for the future of human exploration. The station's extension to at least 2020 will allow it to reach its full potential as an unprecedented orbital laboratory. Most of you know that this engineering marvel almost didn't make it to orbit, hanging on by only one crucial House vote so many years ago. But now, we've had humans living aboard the ISS for more than 10 years, 24/7. Through turmoil and natural disaster on Earth, the station has continued its 16 orbits per day, traveling about the distance to the moon and back each day. A beacon of international cooperation and of what we can achieve when we set our sights on grand challenges. With ISS as our premier laboratory for microgravity research and technology demonstrations, over the next 10 years, we'll continue to collaborate with other nations to live and work together in space and perform cutting-edge research and technology demonstrations that are critical to our eventual exploration into deep space with humans. The ISS is the most realistic analog we have to test life support and other technologies, ensuring they function in space, and most importantly, that they are reliable. A journey to Mars will require robust systems, ensuring that crews stay healthy and safe. The station is the start of our journey outward. I've said before, our ultimate goal is Mars, but we have a lot of work to do before we can get there with humans. After all, with today's technology, it would probably take about 8 to 12 times the mass of the International Space Station to send humans on one round-trip mission to the Martian surface. So, for starters, we'll need lighter weight material, more efficient in-space propulsion systems, and we'll need to learn to live off the land so that we can pack less for this grand journey. Putting a human mission on the surface of the red planet has been compared to precisely landing one two-story house on a small island in the Pacific, right next to another that was autonomously landed in advance. This will require a host of technologies beyond the systems we use today to land our robotic explorers. We do have the benefit today of extensive maps and information about the Martian surface. When the Mars Science Laboratory, also known as Curiosity, starts roaming around the surface next year, it's going to add to the massive amounts of data we have about Mars. Its geography, its atmosphere, its chemical makeup, radiation levels at the surface, and much more. We also hope to field a sample return mission from Mars with international partners before we ever send humans there. All of that is to say, there's going to be a lot going on for our destination in the coming years. But let me get back to our starting point. The ISS is going to give us a lot of good information that we will use to expand our human exploration efforts. Foremost among that information is a deeper understanding of human health in space. Among many things, we have a lot to learn about radiation and bone loss, high reliability life support, and how human beings react to being in a closed environment in space for months, even years at a time. The nonprofit organization we're creating to enhance our use of the U.S. side of the station as a national laboratory will help us reach more potential users and strategize about our own work on station. We're going to get industry, academia, and other government agencies more involved. Their expertise, enthusiasm, innovation, and entrepreneurship will greatly advance our national goals. Through the science, research, and technology demonstrations conducted on the National Lab, we will build foundational knowledge, advance economic competitiveness, and prepare for the grand journeys ahead. Just yesterday, we received our first decadal survey on biological and physical sciences in space, entitled Recapturing a Future for Space Exploration, Life and Physical Sciences Research for a New Era. This will provide us guidance to develop a 10-year strategic plan to maximize utilization of the ISS. You may know a lot of the specs on the ISS. In addition to the US Destiny Laboratory and Russian Zvezda service module, there's the Canadian robotic arm and dexterous manipulator, and the European Space Agency's Columbus and Japanese Aerospace Exploration Agency's Kibo laboratories. ISS houses 34 research racks. These include super cold refrigerators, human research facilities that enable researchers to study and evaluate the physiological, behavioral, and chemical changes induced by long-duration spaceflight, special racks for working with liquids and hazardous materials, a growth chamber for growing plants or microorganisms or even small arthropods. ISS also has 22 external locations for experiments. The Japanese plan to have fish in space. The Russians have a greenhouse. Yeah, you get the idea. There's an incredible diversity of research going on 250 miles above us with incredible potential. Any mission to Mars is likely to be a global effort, and the partnerships and friendships we have developed in the construction and operation of the ISS have forged a path for us that we could not have foreseen at the station's inception. The ISS is a blend of goals among the participating space agencies, and it is a truly beautiful in that regard alone. As we approach the massive undertaking of a Mars mission, I look forward to the many contributions that others, partners from internationals, industry, and academia, will bring to the table. Certainly as a child, I could not have imagined that a vehicle the size of a football field, with more livable room than a conventional 5-bedroom house, would orbit above us. The U.S. solar array surface area is nearly an acre, and large enough to cover 8 basketball courts. As easy as we've made construction look, I don't think enough people realize that we have created one of the most amazing engineering achievements in human history. Last year, the National Aeronautic Association recognized ISS with its Collier Trophy, which honors advances in aviation and aerospace. In many ways, the ISS traces its lineage back to the first planes and leaps forward in propulsion and space technology. Looking forward, the ISS will help us make the great leaps that in the last century produced an aviation industry from the Wright brothers' first 12-second powered flight and that first sent us peacefully into space a little more than a decade after the first long-range rockets, originally developed for war, were exploding on launch pads. Just take a look at the station's water recovery system, as well as the extensive knowledge we've gained about human-robotic interaction. Exciting examples of developments are technologies such as the lab on a chip that enables explorers to quickly examine their environment for pathogens, and experiments with microencapsulation that enables drugs to be targeted to problem areas in the body. These have all come from the station just during this ramp-up period. They're applicable to the lives of people here on Earth, even as they've helped us to make the next advances in space exploration. A mission to Mars will require the utmost of our innovation, skill, and perseverance. But it's the kind of challenge NASA relishes and to which we've always risen throughout our history. In parallel to the development of the launch and crew vehicles required for deep space exploration, NASA will develop the in-space technologies required for such journeys. We'll build the technological foundation from which to reach an array of destinations. And, as I mentioned, it will be an international effort, with many nations joining us in the global space exploration enterprise. What NASA does best is focus on the space frontier, those things that aren't yet possible, but are achievable if we work hard toward them and marshal the best of our energies and talents as a nation. As a global people concerned with human achievement and exploration. Even in these difficult fiscal times, the President's fiscal year 2012 budget reinvigorates NASA as part of a national focus on research, technology, and innovation. It gives us the means to win the future. And by dedicating ourselves to challenging missions like Mars, we'll be winning that future by helping our nation create new capabilities, high-tech jobs, and new job fields, and inspiration for a whole new generation. Right now, our #1 priority in the near term is safely flying out the shuttle and carrying out our research and development activities on the ISS in a manner that maintains the safety and well-being of our U.S. and international partner flight crew members. We're working steadfastly to plan an integrated, comprehensive human spaceflight program. This will include the Heavy Lift Rocket, or Space Launch System, SLS, and Multipurpose Crew Vehicle, or MPCV, that will be crucial to exploring all of our beyond Earth destinations. We'll release plans for these critical spaceflight systems later this year. We'll leverage the assets and expertise gained from the Constellation program to ensure early successes with the SLS and MPCV. America is the nation we are today because of the technological investments made in the past 50 years. Our lives have been greatly improved by directing scarce resources toward exploring space in ways that spin off technologies for the betterment of humankind. Knowledge from weather and other Earth science spacecraft, efficiency improvements in both ground and air transportation, biomedical applications. They have all benefited from our nation's investment in exploration. NASA space technology makes a difference in our lives every day and can be a spark to an economy that is becoming more technology-based over time. NASA's success over the past 50 years have inspired countless people to pursue science, technology, engineering, and mathematics careers. And the outcome of NASA's endeavors, both in technology advancements and intellectual capital, has transformed our world. NASA has had its failures as well. But in every case, we've done our best to learn from those failures and incorporate those lessons into our follow-on work. NASA's renewed focus on innovation and technology is vital. By investing in high-payoff disruptive technology that industry cannot tackle today, NASA matures the technology required for its future missions in aeronautics, science, and exploration, while proving the capabilities and lowering the cost for other government agencies and commercial entities that want to get to space. Consider for a moment how the architectural options for human exploration of our solar system will change when reliable commercial access to low Earth orbit, propellant depots, inflatable habitats, and advanced in-space propulsion technologies are available. For our science missions, consider the improvements possible from new optics, lightweight materials, structures, and power systems and high bandwidth communications. Consider the efficiency gains in radiation shielding and life support systems that may become possible from improved knowledge of human adaptability to the space environment gained through scientific experiments on the International Space Station. All this applies to human travel to Mars. The President's fiscal year 2012 budget funds a diverse array of human spaceflight programs that maximize our use of current capabilities, such as the ISS, facilitate innovative approaches to ensure U.S. leadership in low Earth orbit, and position us to explore the frontiers of deep space. As we increase our capabilities, we'll apply them to many different types of missions and move on to the next challenge incrementally. We need to get started on a lot of these technologies today, and we will. Over the next decade, innovative technology investments are required to bring future missions such as exploration of near-Earth objects, the Moon, or Mars within our reach. These transformative technologies will reduce the cost and risk of future missions. Achieving great things also involves taking informed risks. Landing on Mars will never be a low-risk venture, but an informed risk-taking strategy commensurate with the agency's goals and expectations is not only acceptable, but required. How else can we accomplish the grand achievements our nation has come to expect of NASA? At NASA, a goal of the President's innovation strategy is to reposition the aerospace community on the cutting edge, pushing the boundaries of our aerosciences with the technical rigor our nation expects of its space program. Innovation, education, and technology development will be essential to America's success in the 21st century global marketplace. They will be required for us to reach new destinations in the solar system and are the engines that will create economic opportunity and lower costs for these massive undertakings. This is where we are today. I'm looking toward Mars, but I'm looking at it as a part of a bigger picture. We can't have tunnel vision. We'll achieve this vision through stepping stones and produce value for the American taxpayer on the road to Mars. This will be an incremental journey, step by step by step. I know my granddaughters will be witnessing humans arriving at Mars. Like the President, I believe such a journey is possible in my lifetime. But what I know today is that we have an amazing engineering resource in space right now, the International Space Station. And we're moving out on the innovation and technological breakthroughs that are required to get us to our neighboring planet. I look forward to hearing what all of you have to say about humankind's next big adventure. And I thank you for the opportunity of addressing you today. Thank you very much. I am told that it is okay to take some questions. Chris says that's okay. So I will try to do that. We have some time. Don't be bashful.
We have a microphone that's going up. Yes, Rick Lopez with LPAC TV. In a recent hearing held by the Subcommittee on Science and Tech, a lot of the congressmen had expressed that this so-called transition from constellation to commercial was not very clear. And in fact, to me, it seemed more like a shutdown of our manned space program than a transition. And also Dr. Scott Pace, who works at GW, had also expressed in his written testimony that the transition was inadequate and incomplete. How do you respond to that? And also, how can we take our exploration capability seriously when we don't have anything to replace the shuttle thus far? Thank you.
Rick, I think my response would be nothing is farther from the truth when people say that we're shutting down human spaceflight, or the human spaceflight program. Human spaceflight is still as vibrant as it has ever been. We have been transporting both American and international crew members to the International Space Station using the Soyuz spacecraft dominantly, as a matter of fact, since the Columbia accident in 2003. And some of you will remember back that it was following the Columbia accident the decision was made that we needed to move on, and that the United States needed to get back to the business of exploration, going beyond low Earth orbit. Operations in low Earth orbit is critical. The International Space Station, as I said, is our anchor for human exploration. But we as a nation, if we want to continue to say that we are the leaders of spacefaring nations, we have to be able to reach beyond low Earth orbit, and that's what we're about doing. There is no question that the dream of the vision for space exploration, which would have had us about flying another vehicle within the next year, had it been funded appropriately and had it been carried out adequately, but that did not happen. And that's water under the bridge, and we can debate that forever and ever and ever, but that's all history. Where we are today is where we are today. And what we are doing is we're on the cusp of actually realizing what I think is a viable commercial capability of gaining access to low Earth orbit. The question of cargo to orbit is moot. I hope there is no one who will argue with the fact that the commercial entities that are on the horizon today will be more than adequate to deliver cargo to the International Space Station. The challenge is crew, is commercial crew. And that challenge is because whether I'm doing it or whether commercial entities are doing it, getting humans to space is difficult. You know, we just need to understand that. We are working diligently with our commercial partners, industry partners. I don't like using the term commercial. There are industry partners, and in many cases they are the same industry partners that we've been working with for 50 years. So we're working diligently with them to enable them to generate what I think will be considered a commercial space industry. And that's not just launch vehicles. It's destinations in low Earth orbit. It is other outposts, whether they be inflatable modules or whether they be commercial space stations. I always like to refer people back to a time that is much too early for most of you. And it's back when I became an astronaut in 1980, when there was still a space transportation system. And it was a three-pronged system that consisted of a space shuttle, an orbital maneuvering vehicle, and orbiting space station or stations. The orbiting maneuvering vehicle's purpose was to go from station to station to the moon, from station to other places. And in that time, 1980s, late 1970s, early 1980s, we actually envisioned privatizing the shuttle. That did not work out, and it was brought to an abrupt end with the Challenger accident, to be quite honest. So we have an incredible opportunity to turn the clock back. This nation envisioned doing what President Obama has us trying to do today. We envisioned doing that in the 70s. And we were actually making headway to doing that in the 70s. It requires a lot of effort, a lot of sweat, a lot of risk, a lot of sacrifice, and yes, a lot of loss along the way. And so any of you who think you're in this for the long run, you need to get ready. You know, we will lose people. And when that happens, we cannot give up. Great nations don't give up just because they encounter adversity. So I would plead with you in this forum. I don't know whether there's a session that will talk about risk at all, but it's something that needs to be on our tongues and on our lips every single day if we are true explorers. How many people left the east coast of the United States just trying to cross the Mississippi and never made it? Or how many people tried to cross the great, the continental divide and never made it? We would not be the nation we are today were it not for true explorers, people who realize that exploring requires risk and loss. So I think we're okay. Maybe one? Okay, a couple more. All right. Well, maybe not. Yes.
General Bolden, Ed Hudson and Hamilton, that's great. Question for you that has
a personal perspective as well as I'll say an institutional perspective. When we look at missions to Mars, ultimately are looking at the extension of human time in space and microgravity well beyond the 1 year kind of horizon that we're really familiar with. What's your view of our readiness to extend a human stay on the station to more than a year? And would you personally take that risk with our present state of knowledge?
Would I personally take that? I would personally take that risk in a heartbeat. And some of you have heard me say this before. I am married, and I love my wife, and I want to stay married. So while I would personally accept that risk, I'm not sure what she would say when we had that I don't know. We have not had that conversation. No one has offered me that opportunity. You know, John Charles, there are a lot of you with whom I've worked before. John Charles and I have worked years ago at the Johnson Space Center. John may have an opinion about this. I think in terms of the human capability of living on station for more than 6 months, I think we're there. You know, I trained with Vladimir Titov, who, although he flew a year later, Vladimir at one time held the world record for long duration spaceflight at 366 days. And we have had someone live in space for the duration of what we expect to be the time to go to Mars and return. So that's been demonstrated. And Vladimir walks around today, as far as we know, not significantly you know, harmed by that experience. Do we have to rehabilitate individuals when they come back? Yes, we do. We have to rehabilitate individuals when they come back from a flight on the space shuttle of 12 days. The rehabilitation gets longer when someone's exposed to microgravity for longer periods of time. But we're confident that in terms of rehabilitation, conditioning on, you know, in orbit, we think we've got that. The big challenge, and some of you can challenge me on the big challenge, but I still think the big challenge is radiation. And you know, that is what we have got to come to grips with. We've got to figure out how we understand the threat. You know, we've got to do some testing. There are lots of things that we have to do that remain challenges in. But I think if we decided to do it, we could keep people on the International Space Station for very prolonged periods of time. We could stretch it out to, if we wanted to do a 500-day mission or something, if we wanted to do that. We just haven't gotten there yet.
Hello, General Bolden. This is Dan Hussein, American Patent Agency. I have a question for you. You suggested that the approach to Mars is by an international approach, with the way the ISS has been done. My question is, can you give reasons why you think this is the most appropriate way to go to Mars as opposed to nationalistic type?
I can give you several reasons. One is money, perhaps the biggest. The second is expertise. The third is ideas and ingenuity. We don't have and let me explain that. I learned a long time ago, and through 34 years, you know, serving on active duty in the Marine Corps, as much as as proud as I am to be an American, we don't have a corner on the market on smarts. There are things that other nations do in terms of exploration that we just don't. We either don't do it because we didn't have to, and they did. If you look at engine technology, for example, you know, one of the reasons that we struggle right now with heavy lift propulsion, we would love to have the capability of doing a LOX kerosene or LOX RP propulsion system. Anybody in here from I know there's somebody from Aerojet. Anybody from Pratt & Whitney? Okay. I mean, you know, you ought to talk to these guys. That's a challenge. We can do it, but we have not asked our industry to do it on a grand scale yet. But we have to do that. You know, there are a lot of reasons. We can use LOX hydrogen, we can use LOX RP. There are a lot of really good reasons for wanting to go to LOX RP for the nation. And not just, NASA can't do things for NASA anymore. The fiscal constraints under which we live today, everybody listen to this, okay? Things are not going to get markedly better financially in the foreseeable future. Now, that may be bad news. You know, let's face fiscal reality. The reason we're struggling, and I don't even know if I'm coming to work next Monday, you know, well, I'm coming to work on Monday. I don't know whether I'm going to be able to stay. Is because the nation is having to come to grips with reality. We have known this, geez, probably for decades, but we just kept kicking the can down the road. We can solve this problem. We will solve this fiscal problem. Not many of us in this room are going to be involved in that. We've got to live with it and make do. But when I say we are going to Mars, we are going to explore, and we're going to do it incrementally, step by step by step. Don't just stop thinking about grand things that we're going to do it in one fell leap. You know, we did that with Apollo, but Apollo was destined to go to the moon, and that was it. You know, and it had an overarching purpose, and that was to beat the Soviets. As much as we'd love to, you know, to glory in that hour for this nation, I don't know that we would have done Apollo had it not been the challenge of beating the Soviets. Today, it's in our human DNA. That's why I think we're going to do it. And that's why I think we're going to struggle through this, because every one of you sitting in this room wants to explore. You wouldn't be here if you didn't. Every one of you sitting in this room, even if you're representing a company and it's your job to be in this room, you're probably not in that company if you didn't believe in exploration. So we're going to do this. If we don't lead, someone else will. And there are a number of international partners that we have that really want to do this. So we've got to be smart. We've got to take risks. We can argue all day about my trust in industry. We have to. You know, I have to have a reliable industry partner in whom I can believe and I can trust, because we are not going to have the fiscal wherewithal to be able to explore and provide access simultaneously. Not in my lifetime. I know not in my period of time as the administrator. So we need to become realistic. We need to be honest with each other. We need to fight and fuss the way that I have people doing at my headquarters about how we do it. We can do it. There are thousands. Literally, the two rocket guys here will tell you, there are literally thousands of ways to leave this planet. We just have to decide how we want to do it and get on with it. Yeah, follow up.
What did you learn from ISS in terms of maintaining such a massive coalition of countries that have such divergent interests and keeping everyone focused?
Ooh. The question was, what did we learn from ISS about maintaining cohesion? I'm using some words you didn't use. Maintaining cohesion among very diverse partners with very different interests. I think, and John Grunstell's down here, John, and anybody else can help if you want. I think the biggest thing we learned is that when humans come together for a common cause, what they accomplish is unbelievable. No one can predict what human beings can accomplish when they are either forced or by choice put their differences aside and look at what they have in common. I've told people my story about my last flight on the space shuttle. When I was here at NASA headquarters as the assistant deputy administrator, and you know, one of my mentors at the time said, "Hey, we want you to go back to Houston and command a shuttle mission." I said, "That's great. What is it?" And they said, "Well, it's going to be the first joint Russian-American mission." I said, "Forget it. You know, I don't have any desire to go fly with any Russians. You know, I'm a Marine, and I don't want to do that." And very calmly he said, "Settle down. Just, why don't you think about it? We've got two guys who are going to be here in town, Sergei Krikalev and Vladimir Titov, and why don't you have dinner with them tonight and see what you think?" And in one evening over dinner, talking about families, talking about kids, talking about our dreams and aspirations and talking about things that we had in common as opposed to what divided us, I went back the next day and I said, I'm ready. Let's go do this. So it is having people of common aspirations and dreams and visions come together who think about how we can do something as opposed to what makes us different and why we can't do it. That's been the key to the International Space Station. And I think when people talk about the Nobel Peace Prize for the International Space Station, that's been bandied about every once in a while. I think it's incredible. You have, right now, 15 member nations coming together, 250 miles out in space, with all kinds of stuff going on down here on this planet, where militaries of the member nations are not always cooperating with each other and are sometimes on different sides of the issue, and yet we are combined and united in exploration, which is what the International Space Station is. That's the lesson that we should learn from. Yeah. Yes?
Bolden, could you comment on the intriguing technology that Candy is working on?
Oh, Graham, I will try. Okay. The question is, can I comment on the Vasimer engine that Dr. Franklin Chang Diaz is developing? And I will try. Franklin is a dear friend of mine. Franklin and I, we actually interviewed this. I want to make this longer than you want, because this is a phenomenal story. If you don't know Franklin Chang Diaz, Dr. Franklin Chang Diaz, very quickly, born and raised in San Jose, Costa Rica, at the age of 7, told his dad he was coming to the United States to be an astronaut. His dad said, forget it. Said, go back to school. 10 years later, graduating from high school, he said, it's time for me to go to the United States. His dad said, for what? He said, because I'm going to become an astronaut. And they went back and forth. His father finally gave up, said, okay, look, I have some friends, engineers in Hartford, Connecticut. Here's a one-way ticket to Hartford, Connecticut, $50 in cash, and a note. The note said, this is my son Franklin, about whom I've spoken. He doesn't speak English, but that's okay. Humor him for as long as you can, and then send him back home, and I'll reimburse you for the ticket. And so that's how Franklin came to the U.S. Almost flunked out of the University of Connecticut the first year. Taught himself English, went on to graduate with honors, went to MIT, earned a PhD in plasma physics. Today, he is considered to be one of the world's foremost plasma physicists. Interviewed with me for the astronaut program in 1980. We were selected together, flew our first flight together, flew my last flight together. An incredible individual, a hero in Costa Rica even today. He has a company called Ad Astra that is developing a Vasimer engine. It is essentially, I don't want to get this wrong, it's like an ion engine. Right now I think he's using xenon. It could use hydrogen, argon, anything, and it essentially heats up the propellant as it goes through around the engine. It's used to cool. We're talking about a fusion reaction, okay? So nothing you can use to contain it, so he flows the fuel around it and creates a gaseous jacket. He preheats and gets the molecules going, and then it comes back around and it's used as a fuel. Theoretically, it's a constantly accelerating engine that theoretically, again, would get us to Mars in half the time that it takes us to go now. That's all I'm way out on a limb here, Graham. So, and please don't anybody quote me on that, because Franklin will just kill me. Yes. Okay, one more, and that's it. Thank you. Yes.
Denise Chow at space.com. With the current vision to have a manned mission to Mars sometime in the 2030s, how important will it be to extend the life of the space station beyond the next decade or so, and how confident are you that NASA and the other international partners will be willing to support that extension?
I'm sorry, I missed how critical would it be to extend the life of the station even beyond 2020? Is that what you said?
Yes, yeah. And how confident are you that NASA and the other international partners will be able to support that?
Right now, we actually are working on certifying the International Space Station to, I think, 2028, and that's with the agreement of the international partners. Now, whether we decide to do that remains to be seen. I think we're trying to accomplish one hurdle at a time. We still need for the Canadian government to approve the extension of the International Space Station, and then we will have all of the international partners on board. So I like to remind people, it is truly it's a treaty, and so it's an international endeavor, and all the partners have to agree. So we're still waiting for the Canadian government to endorse extension to 2020. you know, my guess would be if it continues to be as productive as it is today, and we further enhance our use of it as first a national and then an international laboratory, we may find that we want to extend it as long as we can in order to help us to get to Mars. But it's kind of premature to say right now. Yeah. Okay. Thank you all very much. You've been incredible. I appreciate it.